Hello everybody. So today I will talk about calculus. The topic today is about application of derivative. So now I will show you how to answer. Here is about the question. We have the Roche limit. So we have the situation in here. An asteroid is trapped by a planet's gravitational force and begins orbiting the planet along the path y equals to 4 minus x squared, so that the Earth is located at 0, number 2. The Roche limit is estimated as 1.3227 units. If the distance between the asteroid and the Earth somewhere along the path is less than 1.3227 units, the asteroid hit the Earth. Should we expect a collision? So now I will show you how to answer. Here is about the picture. If we look carefully about this one, we can see that if we graph based on y equal to 4 minus x squared, they should be like this. And the location of the Earth, that's about 0, number 2. So that should be in here. Just like similar for the figure. And this is about the comet. So they want to find the minimum distance between the Earth and the asteroid. To do about this one, for example, we have y equal to 4 minus x squared. Let's say x equals to a. That means we have one location on the curve and we have 8 in here. Because s equals to a, and we can put a goal here. And we got about y equals to 4 minus a squared. So this one we have 4 minus a squared. We want to find the distance between the comet and the Earth. To do about this one, we have the formula of the distance. That is about d equals to the square root. We have sa minus sb to the power of 2 plus ya minus yb to the power of 2. Let's say this point in here is about a, and this point of the Earth I will put about b. So we use about coordinates of a minus coordinate of b. So about xa, we have a in here. Xb, we have number 0 in here. Plus ya, that is about 4 minus a squared. Yp, that is about number 2. Now, we need to simplify this one. So we have a squared plus 2 minus a squared. Now we need to expand this one. So a squared minus 4a squared, we have the square root of 4 minus 3a squared plus a to the power of 4. Now, we need to concentrate about this function f of a equals to this one. To find about the minimum distance between the asteroid and the Earth, we need to find first the derivative of the function. First derivative of number 4, we have 0. First derivative of a squared, we have 2a. First derivative of a to the power of 4, we have 4a to the power of 3. Now we need to simplify, and we have negative number 6a plus 4a to the power of 3. Now we need to put first the derivative of the function equals to number 0. That means we put this one equals to number 0. Now we have 8 and 8. We can do about factorization. Now we have the solutions in here. That's about a equal to number 0 and negative number 6 plus 4a squared equals to number 0. So we put negative number 6 go to the right, and we divide both sides by number 4. So we have 3 over 2. Now we put the square root for the both sides, and we have 8 equals to the square root of 3 over 2 and the square root negative with the square root of 3 over 2. After you got about this one, we can put back to this equation. So when a equals to number 0, you got about the distance in here 0, 0, so the square root of number 4, we have number 2. When a equals to the square root of 3 over 2, or maybe a equals to negative with the square root of 3 over 2, you got about d equals to the square root of number 7 over 2, and this is approximate about 1.3228. So this is about the maximum. This one is about minimum. Now we need to compare conditions. We have 1.3227, but we calculate the minimum is about 1.3228, and this number is greater than 1.3227 because the question, if the distance is smaller than this one, you know that the asteroid hit the Earth, but the minimum is greater than the number in here. So we can say that there is no collisions. This is the end. Thank you for watching.